Hi everyone. Now we're going to be looking at the graphs and statistical tests for achievement standards. So here we've got the Physics 2.3 results in a bar chart. We've got our grades along the horizontal and percentages on the vertical. So the lengths of the bars represent the percentage of students who got each of the grades. There's two types of bars. There's blue ones and red ones. The red bars represent the 2017 students, and the blue bars represent all the students from 2012 to 2016, our historical performance. So just looking at this, we can see that a few less students got not attempted, a few tiny less percent got not achieved, pretty much the same got achieved, a few less got merits, and a few more got excellences. It's possible that it looks like maybe the merits turned into excellences. This could be good. Maybe the red bars have been pushed down towards the higher end of higher grades. Well, we can refine that maybe and possibly into something a little bit more exact. And that's what statistical tests do. So let's scroll down. There we go. Oh, a little bit too far there. What we're going to be using while we're down here is a thing called the chi-square test. And we're going to be using in particular the linear by linear association chi-square test. So that's that row. And we are interested and only interested in the exact significance, two-sided, that column. So in fact, we're only interested in one number, that number there, 0.356. Let's remember that number. So if I scroll up, I'll tell you what that number means. So here we have the table with the actual data in. So it's the graph in table form. So we've got our grades down here, and we've got our years across here. But we've got something extra. We've got a total. So this column here gives the total number of students and their percentages who achieved each of those grades. Okay, so this is important. What we've got here is this is what's happened from 2012 all the way up to including 2017. Our statistical test says what is the chances that the 2017 students, these ones and these percentages, were selected randomly from our whole population. And in particular, what's the chances that that selection represents a shift in one direction or the other? This is the linear by linear association. What's the chances that the distribution is pushed towards the end, that actual improvement has taken place? Well, the chances are 0.356. That's that result. That's what it tells us, which is quite a big number. 0.356, the chances that the improvement is just random, just year-on-year variation. It's just a good year. 35.6%. That's quite large. You wouldn't want to make a firm statement on that, and that's what statistics is all about. So I've given you three options, and there's three levels. There's nothing's happened. If the p-value is greater than 0.1, it's just same thing as usual. We say it's similar. If the p-value falls between 0.1 down to 0.01, we say that it's either notably better or worse. But if the p-value falls below 0.01, we say there's a significant difference. It's a significant improvement. Unfortunately, not in this case. So what you do is you choose the appropriate test. There we go. So the Physics 2.3 grade distribution is similar to previous years, and the p-value is 0.356. 35.6% chance that the 2017 student, that improvement we think we're seeing, there's a 35.6% chance that it's just random. So no, we don't make any firm conclusions. It's the same thing, same as usual. Now let's look at one that's not the same as usual. So I'll scroll down a bit. That's the one. Now, graphs are great. You look at that. Something's happened. All the red bars have been pushed down here. Imagine it was some, I don't know, silly putty or something. You've got the bars and you'll push them towards this. The thing's distorted, it's skewed, is the fancy maths word. Looks like something's happened here. Less people have got the standard, no one's got standard not attempted. Less people got not achieved, less people got achieved, more have got merits, and even more have got excellences. It looks like an improvement. And it is. As we scroll down, let's ignore the table, don't care about the table anymore. Go to your chi-squared test. Here we go. Linear by linear association. That row there. The exact significance, two-sided. This is looking at, you can tell you about, two-sided means it can tell you about things getting worse as well. Anyway, the chances of that skew, that improvement is 0.006. 6% chance that it happened randomly. In other words, we're very, very sure that it's not a random variation. We're sure that something important has happened, an improvement has happened. So we select this bottom value because the p-value is less than that trigger value of 1%. So here we go. Would write down, by conclusion, physics 2.1 grade distribution in 2017 is significantly better in this case than in previous years because the p-value is 0.001. There's only a 0.1% chance that that shift is the result of just a random selection. Something real has happened.